Hello everyone, in this video we will continue with what we left off from video number 3, and from video number 3 we have found the solution for the integral number 2. Before I continue on, I would like to review what we have done. So for this triangular waveform, what we need to find is we have to find the Fourier coefficient A3. And to find A3, we have to get the formula for AN. And for AN, what we have is there's VT. And we have to involve all the intervals that we work with. Okay, so therefore, we are having this integral, and we divide this integral into 2. So we break that into 2. And we have found integral number 1 already. Okay, integral number 1, integral number 2. So what I'm going to do next is I'm going to find integral number 3. Okay, to find integral number 3, to substitute in here in order to find my A3. Okay, so integral number 1, I have found that already, which is equal to this. Okay. Integral number 2, I also found that is equal to this. So now we are going to continue with the integral number 3. Okay. For integral 3, I should have it with the integral as t over 2, t, and 2v max times cos of 2 pi 3 over t times t dt. Okay, so again, I am going to bring this across the integral sign. So I will write this as 2v max integral t over 2 to t and cos of 2 pi 3 over t times t dt. So how do we integrate this? So what we need to do is we need to check it our formula sheet to see what formulas that we are going to use to make things easier for us. So I can see that we are going to use formula number 13. Okay, because in this case you just have cos of 2 pi n divided by t times t dt. So we are going to use formula number 13. Okay. So I will make a note here. I'm going to use formula number 13 on page 11 of the Fourier workbook. Okay, so number 13 tell me that I should write it as t over 2 pi n, in this case is 3, so I will write 3, and then multiply that with sine of 2 pi n, so it's sine 3 divided by t. I have to evaluate this at the value of t over 2 to t, apply fundamental theorem, so I should have now f of t subtract f of t divided by 2, and don't forget here is the t, where the t you will substitute in the values for the upper limit and the lower limits. Okay, so this I will may as well bring this across here and see what I can simplify, so that cancel that. Inside the bracket I should have sine of 2 pi 3t. Now I substitute in the t, you see, so here substitute in this t, and I will subtract that with sine of 2 pi 3 over t, and I will substitute in the t over 2. Alright, so what do I have? Now you see, you can cancel that with that, you can cancel that with that, and what I have left with is Vmax times t over 3 pi, and right here I should have sine of 6 pi subtract sine of, you see that 2 can cancel out as well, so I should have sine of 3 pi. Okay, at this point you can use your calculator to figure out sine of 6 pi, which is equal to 0, and sine of 3 pi is also equal to 0. So you basically take this and multiply by 0, so this is equal to 0. Alright, okay. So before, what we have is we have a3 equal to 2 over t, and in here I should have integral 1. I add that with integral 2, and I add that with integral 3. Okay, so don't forget that I have to multiply this one by 2 over t. Okay, so that's substituted in here, 2 over t. So my integral number 1, okay, my integral number 1, let's go back and find my integral number 1. I just want to indicate to everyone this is right here. Okay, so I will write it down. Okay, so I should have subtract Vmax times t over pi squared t squared. And my next one is my integral number 2. Integral number 2, I found it right here. Minus Vmax t. So again, it will be minus of Vmax times t divided by pi squared 3 squared. And integral number 3 is figured out as 0. Okay, so I will have a3 equal to 2 over t. And in this case, let's just adding this 2, I should have minus 2 Vmax of Vmax times the period, pi squared 3 squared, and close the bracket. So let's see what we can simplify. So you see that t can cancel out with that t. Okay, and what I have left now is I should have it as negative 4 Vmax, the whole thing divided by pi squared 3 squared. Can I simplify any further? I cannot. So a3 in this case is minus 4 Vmax divided by 9 pi squared as the final answer. Alright, okay. At this point, I would like to add something. So, if Vmax is given as 120 volt, then what is A3 equal to? Okay, so what you do in this case is, all you do is just write A3, substitute 120 volts in here to figure out this value. Okay, so if you use a calculator, I suggest that you use the whole pi signal and then square that. And if you use your calculator and figure out, it doesn't matter what your calculator is in, like radian or degree, it doesn't matter. If you use the pi button on your calculator, then you should have your answer as A3 equal to negative 5.403796.461. Okay, as 3 significant digits, then I should have A3 as negative 5.40. Okay, so as 3 decimal places, then we should have this as, that is 3, look at 7, so then A3 will be equal to minus 5.404. So if I want 3 decimal places, I should set this number. I want 3 significant digits, I should have number. It's just something on the side here, because I think that I asked everyone this question on the assignment. That given Vmax equal to 120 volts, and you have to give me the numerical value for this Fourier coefficient. So that's what you just have to do. Alright, okay. So this is quite a very comprehensive, very long questions to work with. Okay, I just want to review a little bit before I end my video. So to find the Fourier series, we will have to find the we have to know if this one is the odd or even, or it's halfway symmetry. But in this case, we don't have to worry about that. They just ask us to determine Fourier coefficient A3. Okay, so to find A3, you are using the formulas given to you to find A3, which is these formulas. And because of VT involving 2 equations to work with, so you have to write all of that into these integrals, but including all the interval that you have to deal with. Okay, in this particular part of the interval right here, then what you have is you have a binomial as your VT. So you have VT having 2 terms. This 2 term multiplied by cos of this argument. So you have to expand by multiply this cos inside the bracket. As a result of multiply this inside the bracket, you end up with 2 integrals to work with. Okay, so in this case, now you have 3 integrals to integrate. And what we did, we integrate each one individually, and then we substitute back into our statement for A3. And in the end, our answer is this, minus 4 Vmax over 9 pi squared. So if I give you the value for Vmax, such as 120 volts, then all you do is just substitute into this equation for A3, and then give me the numerical values. Okay, thank you everyone.